Welcome to this video on the evolution of AI data agents. We will journey through 7 decades, from the initial concept to the dawn of a truly self-directing intelligence and the autonomous economy. This program is brought to you by the Series of Thoughts team, as part of the AI Foundation series. Our journey begins with Chapter 1, the dawn of autonomous agents, spanning 1950 to 1995. This foundational era, from symbolic reasoning to the first mobile, perception-driven machines, made everything possible. Key milestones in the early AI foundations include the 1956 Dartmouth Workshop, where the term artificial intelligence was coined. In 1972, MYCIN proved machines could encode specialist knowledge. Shakey in 1987 was the first mobile robot to integrate perception, planning, and action. And the 1993 DEC's knowledge-based agent saw the earliest enterprise deployment of an AI agent. The 1980s and 90s saw the birth of software agents. Berkeley's DIA in 1988 was the first truly distributed agent architecture. IBM's Agent Builder in 1992 provided the first commercial toolkit. The 1995 Autonomous Agents Conference formalized the field and introduced the BDI model. We saw the first agentic milestones between 1995 and 2005. In 1999, NASA deployed autonomous fault diagnosis agents aboard Mars Pathfinder. By 2003, Amazon's recommendation agent delivered a 12% sales lift. In 2005, Google's AdSense agent automated ad placement, generating $1.2 billion in incremental revenue in its first year. Moving from symbolic reasoning to early agents, the 1990s lab was the birthplace of every autonomous system that followed, a place of bold hypotheses that laid the groundwork for today's advancements. Chapter 2 covers the deep learning surge from 2015 to 2023. This era saw large language models transform agents from narrow rule followers into flexible reasoning systems capable of human-level performance. Large language models unlocked agency. BERT in 2018 enabled agents to understand nuance and intent. GPT-3 in 2020 powered the first prompt-driven autonomous assistants. Claude 2 in 2022 allowed agents to invoke external services. By 2023, Gemini proved agents could reason at a human expert level. The React framework is the engine of agency, an iterative loop that refines decisions based on live observations. It continuously cycles through reasoning, tool selection, execution, and observation, closing the gap between thinking and doing. Modern agents utilize 4 memory management paradigms, tuning for different time horizons. Short-term memory handles real-time context. Medium-term memory retains task-specific knowledge for up to 30 days. Long-term memory provides persistent learned policies. Finally, garbage collection ensures latency remains low by expiring stale embeddings. A prime example of a real-world agent is OpenAI's GPT-4o. It boasts a 94% user satisfaction rate across tasks like scheduling, email drafting, and coding. It also saves an average of 3 hours of administrative overhead per office worker daily. The React loop is essentially the brain of an autonomous agent. This continuous cycle of reasoning, tool selection, execution, and observation mirrors human problem-solving, but at machine speed. Chapter 3, Market Explosion, covers 2023 to 2026. Autonomous agents have moved from research labs into boardrooms and global supply chains, rewriting the rules of digital enterprise. The global AI agent market forecast projects significant growth. The market size is anticipated to reach $850 billion by 2030, driven by enterprise adoption. This represents a 35% compound annual growth rate, making it one of the fastest expanding tech sectors. A major milestone is the projection of 1 million agents by 2026. Currently, 72% of Fortune 500 firms report at least one production-grade autonomous agent in operation, signifying the tipping point from experimentation to enterprise standard. The March 2026 registry snapshot shows over 104,500 agents across 15 registries. Agentverse is the largest decentralized ecosystem at nearly 35%, followed by ERC8004 with 17.6%, and Pulse MCP and Moltbook with around 15% and 13.8% respectively. Looking deeper, Agentverse, powered by Fetch.ai, creates a full-stack autonomous economy, running decentralized finance bots and supply chain trackers. ERC 8004 on Ethereum hosts smart contract-bound agents for on-chain governance and automated escrow, designed to be trustless and auditable. In capability distribution, text generation dominates at 59% of registered agents, reflecting an LLM first wave. API integration follows at 31%, showing agents actively connect to external services. Workflow automation and data integration are the fastest-growing verticals. Regarding global agent density, North America and Europe each host over 30,000 agents. Asia-Pacific is the fastest-growing region, fueled by manufacturing automation and fintech adoption, and is expected to overtake Europe by 2028. Chapter 4 covers architectural innovations from 2024 to 2026. Standardized protocols, enterprise memory layers, and robust governance frameworks have transformed agent deployment from artisanal to industrial scale. The Model Context Protocol, or MCP, is the universal adapter layer for the agentic era. It standardizes tool call schemas, allowing any LLM to reliably orchestrate any external service, eliminating the need for bespoke integrations. Tool use standards are essential. Agent to agent, or A2A, defines secure, authenticated message passing between autonomous agents across different cloud environments. React is a unified trace format for reasoning and action, adopted by major AI platforms like OpenAI, Anthropic, and Google. Enterprise memory layers include a Redis-based cache layer for instant retrieval, a Neo4 JBack knowledge graph for persisting entity relationships, a long-term archive for compliance, and an audit trail that logs every React step for an immutable compliance record. The governance and security blueprint mandates zero-trust identity using short-lived by 0.509 certificates. A policy engine evaluates every tool call against risk rules before execution. Data lineage provides automatic provenance tagging for full audit transparency. Our first case study looks at Aurora's car insurance agent. It uses React loops to autonomously gather data and file claims, resulting in 40% faster claims processing. Its long-term memory also lowers fraud loss by 15% by surfacing anomalous risk patterns before payout. The Fetch.ai Agentverse ecosystem, our second case study, boasts over 36,000 active agents managing energy grids and decentralized finance, with an annual volume of $2.3 billion. It also features self-healing contracts that auto-patch security vulnerabilities without downtime. In the academic research case study, Stanford CS329T students built a multi-agent coding assistant that decomposes feature requests into 7 specialized subtasks. This achieved 30% faster prototyping compared to manual coding, highlighting the power of subtask decomposition. The Agentverse dashboard provides real-time visibility into agent health, transaction throughput, and autonomous contract activity. It serves as the command center for this living digital economy, enabling operators to maintain oversight at scale. Chapter 5, Evaluation and Benchmarks, addresses the existential need for rigorous, reproducible evaluation as agents proliferate. The question is how to consistently verify an agent's true capability. Metrics like Agent Bench and Web Arena demonstrate agents achieve a 78% task success rate on multi-step web navigation. They also show a 92% robustness score under adversarial prompts and a median latency of 210 milliseconds per React iteration, fast enough for real-time decision-making. There is a reproducibility gap where only 12% of published agent papers provide a fully reproducible Docker image. The absence of standardized environments produces a plus or minus 15% variance in benchmark scores, making comparisons nearly impossible. Emerging standards include Open Agent Eval, an open-source leaderboard hosted by the Partnership on AI. It uses MCP and A2A adapters for plug-and-play integration. First rankings in June 2026 place Fetch.ai, OpenAI, and Anthropic in the top 3 spots. The Open Agent Eval leaderboard brings needed transparency. Fetch.ai leads with a 91% success rate and low latency. This enables enterprises to make procurement decisions based on verified, standardized performance data rather than vendor benchmarks. Chapter 6 focuses on societal impact, covering 2024 to 2035. Autonomous agents are reshaping industries and raising productivity, but they are also surfacing urgent ethical questions that demand immediate attention. Autonomous agents are driving productivity gains. In manufacturing, autonomous scheduling agents cut downtime by 22%. In finance, AI-driven compliance agents reduce audit effort by 35%. In healthcare, patient triage agents improve ER throughput by 18%. Scaling deployment has exposed systemic risks, creating a trust deficit. These challenges include data privacy, with 9% of agents exposing PII, bias amplification, shown by a 14% gender skew in recruitment agents, and the tension between autonomy versus human control. The future outlook for 2027 to 2035 involves hybrid human-agent teams boosting innovation. Regulatory advancements like the EU AI Act v2 will mandate certified, memory audit modules. Prototype quantum-ready agents will solve complex supply chain graphs in real time. By 2030, we anticipate the autonomous data orchestrator. This enterprise-wide agent network will auto-discover data sources, orchestrate ETL pipelines, and self-optimize costs with zero human intervention for routine operations, generating billions in incremental revenue. A call to action for stakeholders is vital. Executives must allocate budget for agent R&D and governance. Developers must adopt MCP and publish to the Universal Registry. Policymakers must co-create standards for memory auditability and data provenance. Autonomous AI data agents will become the nervous system of every digital enterprise, shaping decisions before we even ask the question. The question is not if your organization will be transformed, but whether you will lead or follow that transformation.